We're going to talk about literal equations, and this is essentially a continuation of the skills we've already learned, how to solve equations. These are equations that are in multiple variables, so you have to have something like x, y, and z, or some combination, multiple variables all in the same equation. Okay? And essentially what you're doing is you're rearranging so that you isolate a variable that is specified. So you would say, okay, well, I'm specifying, y, and so you would just rearrange the equation so that you isolate that variable. Okay? Let's look at an example of this. Okay. 2x minus 3 equals 13. And you're thinking, oh, well, I already know how to do this. I can just use inverse operations and add 3 right there, right? And so then I have, so these go away, and so I have 2x equals 16, and then I know I can divide by 2, and these go away, and then I have x equals 8. That's old news at this point, but we can change this a little bit differently here. So what if I look at something like x minus y equals z? Well, the first thing that you might say is, well, what am I solving for? I have 3 different variables. What am I solving for? Well, let me ask you this. What is this already solved for? This is already solved for z. Do you see that? This is already solved for z right here, because z is by itself on one side of the equal sign. So this is already solved for z. Okay, already solved for z. So what if I say, okay, I want you to solve for x. That's what I want you to do. Okay, so that means that we're going to want to solve for x and get x by itself on one side of the equal sign, just like z is already by itself. So we don't care about z anymore. We just care about getting x by itself. Okay, so let's look at this. Okay, so let's say that if we want to isolate x, this is in the way, right? The minus y is in the way. It is what's happening to x. X is being subtracted by y. So we're going to add y to both sides. And so these would cancel, of course. And we have x equals y plus z. Now on the right-hand side, I have the z plus y. Okay, so now this equation is now solved for x. And I could do the same thing. I could say, okay, well now solve for y if I really wanted to. If I wanted to solve for y, I would need to subtract z, and I need to subtract z, and I would get x minus z equals y, and then I've got it solved for z, and I've got it solved for x, and I've got it solved for y. I can solve it for whatever I want. Okay? So the interesting thing is that you're using the same techniques that you have already learned. Nothing changes. So let's look at a couple of examples here. And I'm just going to zoom in a little bit. Okay, so let's say g equals 6x, and we're solving it for x. Okay, so if I want to solve it for x, x is being multiplied by 6. So if I want to undo this, I have to divide by 6 and divide by 6. And so these 6's go away, and I have g over 6 equals x. And that is my answer there. I really should be doing this in a different pen. I'm going to retry this with a different pen. Okay, let's come over here. Okay, so what about u equals 2x minus 2, and we want to solve for x. So again, we're solving for x here. So x is being multiplied by 2 and then subtracted by 2. So in order to undo that, we're going to add 2, right? Which gives us u plus 2 on the left equals, and then of course these go away right there, equals 2x. And now again, we're making this side more complicated. We don't care. We want to solve for this x. So x is being multiplied by 2, so we can divide by 2. And then that is going to give us, because those now cancel, u plus 2 over 2 equals x. Cool. What about g equals c plus x for x? Well, what's happening to x? It's being added by c, so we're going to subtract c, and then we get g minus c equals x. Right, you see that? Because those cancel out. So g minus c equals x. Okay. What about g equals xc again for x? Well, x is being multiplied by c, so we're going to divide by c on both sides. So those go away, and I'm left with g over c equals x. What about this right here? U equals k over a, solve for a. Well, a is in the denominator, so the first thing we're going to have to do is get it out of the denominator, and we do that by multiplying by a on both sides. Actually, let me get rid of this number 7 here just to make it really clear. So we're starting with a u. There's a u equals ka. We want to solve for a, so we're going to multiply by a and multiply by a over here. Get rid of all that. Multiply by a over here. And so if we're multiplying by a, on the left-hand side we're going to have a u equals, and then the a and a are going to cancel. So we'll have k over 1, which is just k, and we're solving for a here, so now we need to divide by u and divide by u, and so these u's cancel, and we're left with an a equals k over u. See? Nothing is unusual here. What about negative 3x plus 2c equals negative 3? We're solving for x. Okay, we're solving for x. So x is being multiplied by negative 3 and then added by 2c. So we're going to subtract 2c on both sides, right? And so that now these cancel. And so I'm just left with a minus 3x equals, okay, negative 2c minus 3. It doesn't matter which order you write this in. I just tend to write the variables first usually. And so now x is being multiplied by negative 3, so we're going to divide by negative 3 and divide by negative 3. Okay, and really what we're doing over here is we're dividing each of these terms by negative 3. So really what we're doing is we're dividing this by negative 3 and that by negative 3. Okay, and so these negative 3's cancel, and we're left with an x on the left, and we are left with a 2/3 c, or 2c over 3 right there, and negative 3 divided by negative 3 is just plus 1. Okay? What about xm equals np and solve for x? Well, x is being multiplied by m, so we just divide by m and we have x equals np over m. Okay? Alright, maybe some more complicated examples. We've got these basic ones down pat. Okay, so what about something like this? G equals 1 plus 2a over a for a. Now this is interesting because we have a couple of different a's here. We have an a here and an a here. Okay, so we need to combine them just like we would in any other scenario. I'm going to give myself a little extra workspace here. Okay, so let's talk about how this would actually go. Okay, we need to get the a out of the denominator, so the very first thing we need to do, and remember we're solving for a, I'm just covering this up so that it's easier for me to work here. We need to get this a out of the denominator, and we do that by multiplying by a on both sides. And of course over here it might help to write it as a over 1 because that's going to cancel with that. And so now we have ag equals 1 plus 2a. But we still need to get the a's together, okay? So we still need to get the a's together. So if we subtract 2a and we subtract 2a, okay, then we're going to have ag minus 2a equals 1 because those cancel, okay? And notice now that we have an a here and an a here. But if you remember the distributive property, and let's just do a little aside here. Let's just talk about a little aside. A little aside. Let's say that I had something like a times g minus 2, and I wanted to distribute there. Well, I would know to distribute here and here, and so that's going to give me a times g minus 2 times a. And is that not exactly the same thing that I have right here? Can you see that? ag minus 2a. So the distributive property is the backwards version of something called factoring. And really all you're doing is you're kind of doing the distribution backwards. So really we're just taking these, I want my green pen here, we're taking these a's and we're really distributing out like this. You see that? And so then we're pulling the a out, and then we are left with the g minus 2 equals 1. And that's because if I was to redistribute this here and here, I would have this thing again. Okay? So that's really why we're doing this. Okay, so g minus 2. Okay? And so we're solving for the a here. We're solving for the a. So a is being multiplied by this g minus 2. So I want to just divide by g minus 2 and divide by g minus 2. And those g minus 2's cancel, and I'm just left with an a equals 1 over g minus 2. Now I'm going to do one more example here. I'm going to do one more example here to show you the factoring again. Okay, so let's do this problem right here, and we're solving it for a. Let me get all this other stuff out of the way. We're solving it for a, and notice that there are two a's. There's an a here and an a here. But the first thing we need to do is get the a out of the denominator. So if we multiply by ka and multiply by ka, okay, so those cancel. And on the left hand side I have uka, and on the right hand side I have negative 2a minus 3. Okay, and so now I need to get this bunch of a's over here. So if I add 2a and I add 2a, then on the left, and these of course cancel, on the left I have uka plus 2a equals negative 3. Okay? uka plus 2a, And then over here, these cancel. I'm left with negative 3. So I want to get the a out of there because I'm trying to solve for it. And so if I do that factoring or the reverse distribution and pull the a out and the a out, okay, then what do I have left? I have the uk and I have a 2 left. So if I'm pulling the a out front, then I'm left with the uk, and I'm left with a 2 from there. uk and 2. uk and 2. And all of that still equals a negative 3. And I'm still trying to solve for a, so now of course I can divide by uk plus 2, which means I have to do it to both sides. Okay, uk plus 2. And so these whole things cancel, and I'm left with a equals negative 3 over uk plus 2.